Okay guys, so thank you all for sitting down and taking the time to listen to us babble around. I'm going to quickly just introduce to you the topic. You've seen it already: architecting AI autonomy, multi-agent infrastructure on local open source models. So before we get into the nitty-gritty of the tech, let's talk about who we are. We are Tendero. We're mainly friends, but we're also business partners. We've built a software for public procurement. We help companies such as KPMG deal with their public procurement workload better. But here we are presenting how the future is going to look with multi-agents and what we will be doing further down the line and how we will be adopting multi-agent infrastructures and open source models. So quickly about us. Okay, so here's the agenda of the day. Meet Tendero. Then Victor will be taking over with Gen AI pilots and adoption, chaos to structure, so basically how we deal with unstructured data, and local AI hosting for a more sustainable and cheaper way of using AI. And obviously you'll have the time to ask a few questions and we'll be answering them gladly. So quickly about us. Yes, I had a different haircut. I'm the CEO and co-founder of Tendero. The story of us, it started off very simple. ChatGPT came out and I was wondering, can we do something with this? Can we fine-tune it? Can we use this technology to make our workload easier in public procurement? And I went up to my good friend Victor, our technical co-founder, and I asked, is it possible? He said yes. And this is how we embarked on the journey of Tendero. So without further ado, I'm going to give the mic to Victor. Oh, right. Victor just told me to tell you guys a little bit more about public procurement. Okay, right. What we do, Tendero is a public procurement platform, as I've already mentioned, but most of you probably don't know what public procurement is. It's as simple as building a new school, building a new road, keeping the lights on the streets at night. The government needs to pay for all these services and they need to procure them. And procuring them is relatively difficult because it has a lot of documentation, a lot of bureaucracy behind it, and this is what we've taken up to solve and make easier. So what do we do exactly at Tendero? I think most people that have talked to us, we've told them already, but I'll quickly say it again. We are a public procurement platform. We focus on AI-driven solutions to reshape work in public sector contracts. In short, there's a few solutions that we offer. Tendero Free, it's basically a free platform where you can find public contracts across the European Union. Moreover, we offer AI solutions, as already aforementioned. We have a classic chatbot. I think nobody needs an intro to what a chatbot is, right? We do compliance checklists, we summarize, and we offer market intelligence for data-driven insight and better decisions. So, all right, yeah, it's...
Okay, hello everyone. I'll skip through a couple more slides. Ivan has already explained what public procurement is. So yeah, train stations, schools, street cleaning, bridges, anything that you see around that you interact with, that's public procurement. So it's a €2 trillion industry across the EU. Services, works and construction, thresholds and legal basis. Very quickly what public procurement is. Now I'll get into the tech part. So the first part is corporate AI adoption. Now that AI is a little bit maturing, we can finally analyze how it's impacted corporations, how they've benefited from it, what have the pilots achieved in these corporations. So first study came out, MIT, and here's a shocking statistic for you guys. 95% of Gen AI pilots failed in the corporate world. Yeah, so digest it for a second. But it's really not as bad as it sounds. First of all, the statistic measured the direct impact of Gen AI on revenue increase. And if we dig deeper into the study, we actually see that 33% of in-house solutions proved to increase revenue for companies, and 67% of specialized vendor solutions have managed to increase revenue for the companies. What does that mean? Why is the number different than on the last slide? So the last slide takes into account pilots in companies that were simply, okay, we have an HR department, we're going to give ChatGPT or Gemini or Copilot, we're going to give it to our HR department, and then we're going to measure direct revenue impact. Well, you can imagine that doesn't really work. These two numbers here, they speak about specialized solutions. It's about the business finding a niche problem and solving it with AI. So 33% for in-house solutions have resulted in revenue increase, and 67% of specialized vendor solutions have also resulted in a revenue increase. That leaves us with the following opportunity areas for companies. We have low value and low complexity, which is what I just now mentioned, enabling your team to use LLMs for their own work, to draft emails, and so on. Low value and high complexity is basically the same thing, but a locally hosted model. High value and low complexity would be the specialized AI vendors which solve a specific niche business point. It's their entire business to solve that business problem and apply it for the companies. And then high value and high complexity would be the in-house development. This leaves us with the everlasting question in IT, buy versus build. So would we rather, as a company, purchase a software from a specialized vendor, which might cost us more in the long run, every month, paying subscription fees and so on, but that company spends every day of their life solving that niche business problem? Or building, which now seems more and more viable with AI and vibe coding. People seem to be more and more open, and the barrier for entry to building software is much lower. But the problem with in-house building is not really the building of the solution itself, but it's the maintenance and the constant improvement of the solution. That's where the specialized AI vendors gain their advantage, and that's why specialized AI vendors have had higher revenue increases than in-house solutions. Now, chaos versus structure. Here I'm going to talk to you guys about what we do, how we deal with the data we work with, and yeah, let's get into it. So, before I tell you exactly how we solve the public procurement issue with AI, you need to understand the data that comes into public procurement. One public tender has hundreds, sometimes thousands of pages of documentation. Legal, technical, and procedural text, unstructured tables, diagrams, and so on. Sometimes we even have human error and contradicting pieces of information in those tender documents. This is an example of how the data looks. So we have, for example, here we have graphics which hide details about production or about what is required. Our system needs to be able to understand all those intricacies, to understand all the text and where it belongs, what it's related to. That's why we have to use not only just an LLM, we have to use sometimes computer vision, we have to understand certain structures, and that brings me to, one more statistic for you about public procurement data. 46% of tenders have a data quality issue, and 41% of tenders have a completeness issue. So data is simply missing from the tenders. Types of AI systems. We have a general LLM, so this is your ChatGPT. Go, please restructure my email or rephrase this message. Then we have a RAG system. This is usually used for customer support chatbots, any other such small applications. So the way it works is we have a main system prompt which describes, okay, you are a customer support agent, you are to answer the user query using information that is given to you. The information that is given to the model is in a vector store. The vector store is basically a semantic embedding of the information. So when the user asks a question, the system retrieves relevant information to answer the user query and generates an answer for the user. Simple. And a multi-agent RAG or agentic RAG, however we want to call it, is a system which is thought out to solve a specific problem the way that we do it in our own mind. So in the public procurement application, that would be, first, if we give just a bid to a LLM and we tell it, okay, evaluate this tender for me, without any knowledge of public procurement laws or anything like that, the output will be, well, less than impressive, let's say. So for that, we need to give the model context. We need to let it be able to understand the structure of the documents first, then we need to let it understand the meaning and what laws stand behind it, for example, in our application of public procurement. That is done through a multi-agent RAG. So the system dynamically generates itself queries and uses the data it needs in order to provide answers to the user. I'm not going to go into more technical details, but there's different databases that it can access, and it accesses it as it needs. So it's an autonomous system that understands the requirement and understands what it needs to do to answer that requirement. So that's what we do. We built an agentic RAG for public procurement. We understand the documents, we understand the requirements, and for us, the key focuses were, one, memory and context mapping, so transferring the context of the tender from one agent to another. That's the same as tracking and cross-referencing. And then silent failure limitation, which is we wouldn't want our model to hallucinate because it's a very sensitive area, public procurement. So we focused on telling the user that we just simply cannot answer his query rather than answering with a hallucination. These are some challenges, limitations, and threats that we faced along the way when developing this. Challenges are data quality. As I've shown you guys, I'm not going to go over that again. AI adoption and trust. So public procurement, especially because of the nature of the industry, very conservative. So getting people to trust such systems is quite the task. Jurisdiction differences. So again, we have the European Union. We have some laws that are, it's okay. We have laws that are supranational. Yeah, that's the word I was searching for. And then we have national laws. And the national laws really bring difference from country to country. So we had to, each time we entered a new market, we had to specialize our system to fit that market. We had to collect the laws, the directives, the prompts had to be written in the language of the country, and so on. Limitations, data availability. So when we were building, we didn't really have data to test on. We needed bids, we needed tenders. We didn't have that, even though we had participated in public procurement. We didn't have the mass data which was needed. Administrative processes, that's just the nature of our industry. That's how it is. Legal constraints. So, for example, AI systems are not allowed to evaluate tenders at all. It's part of the EU Public Procurement Directive. So it's something that we have to take into account when building such systems. Threats, technological limitation. We know that AI cannot do absolutely everything. We still want the final decision to be left in the human hands. We just want the process to be easier. We want the person to have a clear data-driven decision that they take themselves, because we cannot let an AI model take into consideration commercial issues or how to structure a certain deal, how to find partners, and so on. It's simply impossible. No system will be able to do that at this moment. Again, AI changes so fast that maybe in a year from now I'll be contradicting myself. But at the moment, we believe it's not possible. Yeah. Moving on. Local AI infrastructure. So we do this, and we encourage all our clients to deploy AI systems locally. That is because APIs, so if you build an AI system through APIs, your costs will just skyrocket. If you deploy on cloud, you have data issues sometimes, depending on where you deploy. But with local infrastructure, it's all in your control. So the company has control over the whole system, A to Z. The end of the $20 era for AI. So you guys know, ChatGPT subscription right now is 20 euros. However, they're massively bleeding money. And that is a price anchoring tactic so that everyone starts using the software. And then when the price increases, we still depend on it. Articles right now are talking about a potential price point of around $200 for a ChatGPT subscription later on, especially with models getting bigger and more expensive to run. So, why local infrastructure is more feasible than ever? We have a thriving open source ecosystem. So in the beginning, ChatGPT was basically the only LLM that we could use, at least in my experience in the very early days. But now, any open source, or not any, but a lot of open source models are able to do the same tasks with much less energy requirements. Also with much less data issues, because we can host it locally, we can deploy it how we want, we can fine-tune it, we can do anything we want to those models. Local infrastructure is also better because of data sovereignty. All the data belongs to us. We don't send it around to cloud, to services. Even if we have agreements with OpenAI that they don't train on our data, still, for example, for a legal firm, it is very challenging to use AI systems where they don't know where their data is going. And lastly, but not least, local AI is green AI. So it's much more sustainable and environmentally friendly to not waste, I think as Thomas's previous talk, not waste energy and water in cooling in data centers, but we can deploy our own models locally and yeah, have a much greener infrastructure. Yeah, as Ivan likes to say, eat local, host local. This is a graph that I just now touched upon. So we have in gray, we have the LLM APIs. You know, you pay for every request, every token. We have self-hosted in the cloud, so we have low costs in the beginning. At some point, we actually pay more than we would pay for LLM API, but in time and with scale, the cost kind of flattens. And then self-hosted models, they obviously have a high starting price point because we have to invest into the infrastructure. Somewhere in the range of 40 to 50,000 euros will get you a model that can run LLMs locally. And the price chart would look like this. So we have high price in the beginning with a stable set price for the rest of the usage. But the future, in our opinion, and is actually also something that we do, is a hybrid model. So for the small tasks, for example, for chunking the document, for understanding the sections, for small tasks, we can use local models. We use Llama 3, for example, locally deployed for small processes. However, when it comes to reasoning tasks, we can take our final output from our small models that are locally hosted and use LLM or Gemini API or ChatGPT in order to use that reasoning model for the last portion of the process. Guys, that is it.
Thank you very much for this really impressive presentation, you both. I learned a lot, even we spoke a lot. And I know that working in the niche of public procurement is a big, huge challenge. So that's really fine. Are there any questions to the presentations of the guys?
Hello, thank you very much for the presentation. It was really interesting. I have a question, maybe even a set of questions. The first one would be, do you deal only with tenders, or this solution can be applied to any branch?
Well, we've seen this type of agentic AI applied also in software development, for example. I'm sure a lot of you will be familiar with platforms like Lovable. That's the same way they are built. So it is applicable to any industry. Agentic AI is like developing an AI system specifically for a niche point. I could not upload something else into our current system, then I would get complete garbage out. However, you could build a specialized system for any task in this exact manner.
Okay, thanks. And the second question would be, is it like a boxed solution, or let's say when it is deployed locally, in-house, on-premise, in some company? As I understand, the model is not yet trained, right? And this step of training the model to correctly recognize the documents, to correctly act on them, so is it a part of the service as well?
Sorry, I can barely hear the last part of the question. Can you repeat it?
Yeah, okay. I mean, when your solution is already deployed within a company, training the model, the actual agent, the actual I don't know, service that you provide, is this training to correctly meet the expectations, let's say on the documents or on the other data, is it also a part of your service, or it's up to the user?
Yeah, of course. No, we deliver to the user a fully ready system for them to use, to just plug and play.
Okay.
Yeah.
Yeah, thank you very much.
My pleasure.
Hi. I just wanted to ask about the resource consumption. With LLMs that are provided on the cloud, usually there are a lot of resources that are available for them to use, hosting billions and multiple billion parameters for the LLM to learn. However, if we want to implement something on a device, on a mobile device, for example, or something embedded on an embedded system, does your solution provide accurate service or like accurate solution to the problem?
So your question is to deploy on a device, directly on a device?
In general, you're deploying.
I would say such a solution is difficult to deploy right now on a device. You would need a rig because you need to use LLMs that are 70 billion parameters at least. So I don't think any laptop in this current age can host such a model.
So when you are considering local inferences for your solution, what are we talking about here?
We're talking about a rig that can host LLMs. Oh. So we're talking about, as I mentioned, a 40 to 50,000 euro rig with GPU and CPU power and RAM, enough to run a LLM model, like a large language model. Yeah.
Okay. Thank you so much.
Hi, great talk. What is your experience about handling multilingual documents with small language models?
Yeah, so we deal with that a lot because we worked, for example, with very undocumented languages like Czech or Slovak.
Yep.
And we've noticed that, for example, when we're talking about embedding models, we at first wanted to write one set of queries in English, to extract some certain points, then semantically extract chunks that are relevant, and just generate an answer. But then we saw that it doesn't really work so well, so we wrote our queries in the national language. That's why when we expand, we always need to have some specialist that helps us, first of all, understand the legal ground, so they gives us the laws, everything that we need to have in our databases for that country, and also helps us design those queries and prompts to fit the language.
But are the small language models trained on these low resource languages, for example? That they can actually answer the questions that you are devising?
Yeah. They function. At least on European languages, they function. Yeah.
Great. Thanks a lot.
Yeah, Ivan just mentioned we have not done a country like Estonia just yet. So we will maybe let you know how that goes. But for now, we have not met any major hurdles for that specific problem.
Okay, any other questions? Yes?
Hello, my name is Rohan. So my question was, is it like every time LLM is like 70 billion parameters and sometimes 200 exceed? So does 70B can outperform the 120B parameters like big data sets?
Yeah, so Llama's 70 billion parameter model performs the same as a 400 billion parameter model. That is because they use a much smarter engine. So they don't use all the nodes in the model, like for example, like ChatGPT would do. They use a much more efficient, okay, that might lose you in some points, maybe a bit of accuracy, but it should perform in theory as a 400 billion parameter model, and we've been really pleased with its performance.
Okay.
My question is, are you currently using standard model like ChatGPT you mentioned, or are you willing to fine-tune the model also?
We are actually now gathering a lot of data to fine-tune the model, but we are not using ChatGPT. We're using still an off-the-shelf model, but Llama. Yeah, but we are planning on fine-tuning it. It's just the problem for us is that we need data for each country, so for all countries at once. If we train for only one language, that's not going to affect our other jurisdictions or performance in other jurisdictions. We need a huge data set, in other words.
Okay, any questions? Not, I thank you very much for your presentation.
Thank you, Thomas. Thank you for having us, and thank you for inviting us here. Thank you, everyone.